Welcome to the second Refactoring to Clean Code vlog. My name is Włodek. I teach how to write clean code and I teach how to refactor legacy code into clean code. I write a blog at www.refactoring.pl and today we will be refactoring test code. I am pretty sure you must have heard the sentence by Uncle Bob. Do not treat test code as the second-class citizen. So you should treat test code exactly with the same attention as production code from quality point of view. Together we will be refactoring some code. I will do this by myself at the beginning, but if you want to continue, you can download the source code and continue refactoring by yourself. The name of the blog is Refactoring to Clean Code. So each time I explain slightly differently what is refactoring and what is clean code. So what is clean code? I will ask a different question today. What is bad code? Bad code is code that is tough, difficult to deal with as the time goes on. The productivity decreases significantly and it takes much more time to add new functionality, to correct a defect, or to change any functionality. So what is clean code? In case of clean code, the time needed to deliver new functionality, to change something within our code, is not decreasing significantly. Sometimes it decreases, sometimes it's bigger, but over the time it is kept within certain threshold. How can we achieve it? Of course, through different refactoring techniques. Have a look at this graph. On the vertical line, you can see business functionality. On horizontal line, technical quality. And very often, when we implement new functionality, the quality of code decreases. Sometimes a little, sometimes significantly. That's the red arrow. But then we should perform some cleaning activities against our source code, some refactoring, to increase again technical quality. That's the green arrow. And the more often you change the head and clean your code, the better. So as you see, business quality and technical quality are playing together to reach our customer's goal. Let's have a look at the sources at the beginning. I will not go too much through the production code. You can download the source code and do this by yourself. In short, the production code is already refactored using single responsibility principle, open closed principle, dependency inversion principle, prepared for extensions of this source code into many directions. My main focus today will be put onto the test code. Please have a look. At the top of each test, you have a kind of reminder how pricing for given facility is performed. So in case gym, the client can spend 2 hours for 4 euros, and if they want to stay longer, they pay 50 euro cents for each additional started hour. This is the first test. So the facility, we have the facility gym created, we have visit takes the facility and the number of hours. Here is our client, Mike. Our client visits gym for 1 hour and requests for a receipt. And we can see the output here in HTML. What is the name of the facility, what is the price, and what is the number of loyalty points the customer was given. In case of 2 hours, it is exactly the same, as you see, 4 euros, 100 points. In case of 3 hours, it is slightly more expensive. It should be 4.5 euros, and in case of 4 hours, it is 5 euros. But as you see, if you compare two test cases, the amount of code that is duplicated is significant, and there are only subtle, small differences between these test cases. And in a minute, we will do something about it. We will put duplicated code into separated method, into separated classes. So to summarize, this is the software that counts price, number of points for visit of a client in our fitness club. There is gym, swimming pool, steam bath, and so on, and these facilities, these parts, have different prices. If you want to download the source code, just join my newsletter and you will receive email with instructions how to download it. Then you will be able to perform the same refactoring together with me and later continue. Let's go and perform some live refactoring. I have divided live refactoring into 3 parts. In the first part, we'll extract, achieve, end up with assertion class. There will be 3 steps: extract explaining variables, extract assertion method, and put this assertion method into brand new assertion class. Let me open IntelliJ. Here is our IntelliJ, and you can see between these 2 test cases there is significant amount of code duplicated. So let's put these 3 assertions into method, then into a class. Before we do this, I will extract 3 explaining variables. Ctrl-Alt-V. That's it can be like this. That's facility name. Here it is facility price. And finally, loyalty points. Ctrl-Alt-V, Command-Alt-V on Mac, of course, facility points. I will put these 3 at the top, and then I can mark these 3 lines. Ctrl-Alt-M, Command-Alt-M on Mac, assert facility, and as you see, I have a method extracted. Let's click all here, which is used in each of these test cases. Assert facility. Now, as you see, the remaining test cases are slightly shorter. And in the last step of the first part that I have prepared, I will put this method into a class. When you go into the big refactoring menu on Mac under Ctrl-T, here Ctrl-Alt-Shift-T, you can find extract delegate. So the name of the class will be facility assertion. It contains this method. Let's click refactor. And then, as you see, our brand new class, assertion class, have been achieved. And lots of details, like using XML assertion, is hidden within this class. But here we are only calling this method with different parameters. Let's go into the second stage. Assertion class, the skeleton, is ready. Here it is, but as you see, it is just a constructor, and the method and parameters are put together, whereas the first parameter is a kind of input, the second, the third, the fourth parameter is not output, but these are verification details, verification parameters. So I will divide the group of parameters into input and output parameters. So it sounds reasonable that input parameter should be passed through the constructor, that's the payment, and the 3 remaining parameters should belong to this method or to a set of smaller methods. How to do this? First of all, assertion currently is a field. This was the side effect of extracting class, extracting delegate. So I will inline this field using Ctrl-Alt-N, inline, and remove the field. We have it. This method is not used currently, so let's delete it. And again, I will extract assertion method one more time. Ctrl-Alt-M. Why? Just a minute. Assert facility. Here it is. And this way, the constructor is used only in one place through this method currently. So I will put payment as the first parameter of this method. Alt-Enter, add the parameter. We have it. It's here. Alt-Enter, create field. Here it is. And now, currently, the assertions are using the payment parameter. But if I just do a trick, 1, 2, 3, 4, 5, 6, 7, then these 3 lines are using the field. So I can get rid, Alt-Enter, save delete of this parameter. And this way, as you see, I have divided the parameters into two groups. Here is the second group, here is the first group, input and output. So as you see, to achieve assertion input-output flow, we have inlined the field that was the side effect of extract delegate. Then we extracted the method again. The assertion method then was calling inside it the constructor, and we moved the parameter, the input parameter, from the method into the constructor. So here is what we have achieved. This method is used only once, and currently, as you see, it calls the constructor and then calls the method. Finally, it is time to clean the assertions. Currently, they look like this. So let me replace usage of the constructor with a factor method. If I go into the big menu, I have option replace constructor with factor method. It will be assert that public static assertion method has been introduced. The constructor is private. Let me show you the difference. Now I can use this piece of code instead of calling the method that contains 4 parameters. Let me do this. Ctrl-Alt-N, inline all and remove the method. So it looks that it seems to be more visible. Let me inline these local variables. And the last step is to replace the method assert facility that takes 3 different parameters with 3 methods. Let's extract these 3 methods. The first one, it will be assert facility name. Ctrl-Alt-M, extract method has name. The second one, let's extract, has price. Keep original signature. And the last one, Ctrl-Alt-M, has points or loyalty points, but that seems to be obvious. We are aiming to have fluent interface, so let me add return this. Alt-Enter. Return this. Alt-Enter, make has price return facility assertion. And finally, again, return this. Alt-Enter, make hasName return the assertion. We can change it slightly. It is hasName dot hasPrice dot hasPoints. We can change it. That's it. And this way, finally, I have 3 fluent assertion methods. I have my original method, which I'm going to inline now. Let's inline this method. Inline all and remove the method. Oh, but before we do this, I need to change these 3 methods into public ones. Alt-Enter, change access modifier public. I will inline this method. Inline all and remove the method. Have a look, please. And now each method contains assert payment, hasName, hasPrice, hasPoints. Assert payment, hasPrice, hasName, hasPoints. I hope this is much more visible than it was at the beginning, easier to understand, easier to test, to check if anything is wrong. We know exactly what is wrong. So we replace the constructor call with calling static factory method, then extracted 3 smaller chain methods, put these methods into a chain within one bigger method that was already existing, and then this composed method was inlined. And now it is time for your turn. Homework. I haven't refactored everything. As you see, the test cases still contain a significant amount of duplicated code. And if you go into tutor, you will see that all of the all test cases are significantly smaller. I put a lot of code into one command method, so the duplicated code, duplicated logic has been put into a method, and the only differences which were type of the facility, gym, swimming pool, and the number of hours are put as parameters into a kind of factory method that is used by these 3 cases. You can achieve this shape of the code by yourself. Download the source code and try to do this by yourself. This is everything that I have prepared for this episode. If you like it, please share it with others, give me a comment, put a like to this movie, join my newsletter, and see you next time. That's it. Thank you.